Okay, video solutions for the algebra practice, pages 29 through 31. So evaluate the expression for the given value of x. We have 14 plus the square root of x, which in this case is 16. We know from our classwork that square roots are now positive and negative. So I have 14 plus the square root of 16 is a positive 4 and a negative 4, because a negative 4 times negative 4 is also 16. So essentially we have two different computations now. 14 plus positive 4 is 18, and then 14 plus that negative 4 would be 10. So we're going to have two different solutions. Let's do number 18. So I have 2 times the square root of x, which in this case is 100, minus 1. So I have 2 times square root of 100, we know is a positive and a negative 10, and then we're going to subtract 1. So let's go ahead and do our same change switch here. It's like we always do. So I'm left with 2 times a positive 10 is 20, and then 20 plus that negative 1 is 19. Then 2 times a negative 10 is a negative 20, and negative 20 plus negative 1 is negative 21. Okay? All right. So let's go ahead and go to number 19. A local park is in the shape of a square and covers an area of 3,600 square feet. Find the side length. Well, here's our basic square, and here's our park. We know that the area is 3,600 square feet, and to find the area of a square, we basically take one side times the other because they're exactly the same. So essentially what we're saying is, what number times itself is 3,600 square feet? If we were to actually continue this, that would actually be s squared. But we know that when we're talking about a number times itself, we're actually talking about the square root. I'm just doing it algebraically here to demonstrate that if I have a square and a square root, they would cancel. So in the end, I have my s equals, the square root of 3,600 is going to be 60, and it can't be a negative because distance can't be negative. And we know we're talking about feet, so one side is 60 feet and the other side is 60 feet. 20 and 21 are basically the same. They're just different types of problems, but again, they deal with a square. Okay? And 22. Okay. So let's go ahead and go to solving some equations. Let's just do some basic ones. Not going to spend too much time on this. Let's start with 3. So I have negative 30 equals w plus 8. We always work on the side of the variable first, so I have to get the w by itself. So I have a positive 8, so I'm going to do a negative 8 on both sides. And I picked this one because a lot of you would want to try to subtract. That's the trap. But we know this is an and or a grouping problem. So we have negative 30 and a negative 38. So I'm actually going to add those. And that equals my w. Okay, let's do number 5. Let's go ahead and do our same change switch here. So I have a negative 17. I have to do the opposite, which is a positive 17, or inverse operation. Okay, those would cancel. So I'm left with a equals, that's a negative 10 and a positive 17. So I take the sign of the bigger number, positive, and I subtract. So you got to remember those rules. Okay, we can deal with positives and decimals the same way. So let's go ahead and do this one over here. So I have to get rid of the 4.5, so I'm going to take a negative 4.5 on both sides. Okay, that's going to cancel. And I'm going to be left with my p equals, and I have a negative and more negatives, so I'm simply going to add them up. So that's going to be negative 7.7. If you then want to put the p on the left, that's fine too. You might have an algebra teacher next year that has you do that. Okay. When we have a number in front of a variable, it means multiplication, so we have to do the opposite, which is divide. So I'm dividing by negative 5. Notice my negative 5 and my negative 5 will now cancel. So I'm left with b equals, and you got to remember your integer rules again. A positive divided by negative is a negative. 55 divided by 5 is 11. All right, I have a fraction in front of a variable. So we know from class what we're going to multiply by the reciprocal. So I'm going to multiply by 3 over 1 and multiply by 3 over 1 here. We also call that the multiplicative inverse. Remember from our vocabulary. So these are going to cancel because when we multiply reciprocals, we get 1. And 1 times that n is n. All right, I'll make these into fractions. I can't do any simplifying, so I can multiply across the top and get 108. And if I multiply across the bottom, I just get 1, so that's fine. Let's do one more. Let's do 15. Same kind of problem, except for it's a negative. So I'm going to multiply by the reciprocal. Don't change it to a positive. We don't change the sign. We just flip it. So I'm going to multiply by negative 4/3. Multiply by negative 4/3. So these reciprocals basically cancel out, and I'm left with a equals. Okay, do your sign first. A positive times a negative is a negative. But this time I can do some simplifying. I have a 12 on top and a 3 on the bottom. I know that 3 goes into 3 once and 3 goes into 12 4 times. I want to simplify first so that I don't make the numbers bigger before I simplify. Then I have 4 times 4 on the top is 16. 1 times 1 on the bottom is 1, so I don't need that. Okay? So my answer is negative 16. All right, let's go to the next page. The rectangular triangle is an area A. Write and solve an equation to find the value of A. So we did a couple of those in class. I'll go ahead and do the triangle. We know that the area of a triangle is either 1/2 base times height or base times height divided by 2. It's the same equation. I actually like base times height divided by 2. So let's go and substitute. I know my area is 30. Okay, I know my base is 12. My height is always the vertical altitude that goes straight up from the base. So that's going to be x in this instance. So that's why they have this right triangle there. Shows that it's perpendicular or straight up and straight across. Okay, then my dividing by 2. So I can multiply here. I have 30 equals 12x divided by 2. And that's a fraction. So I have 2 on top, 12 on the bottom. I can divide by 2. So 2 goes in there once, and 2 goes in there 6 times. So I really have 30 equals 6x, and now I can divide both sides by 6, and x equals 5, and my labels were inches. All right. Cumberland Caverns in Tennessee is 44.4 kilometers long. This cave is 10.9 kilometers. A little bit farther. Okay, this cave is 10.9 kilometers longer than Carlsbad Caverns in New Mexico. How long is Carlsbad Caverns? So, I think it's goofed up, doesn't it? Come on, stay there. All right. So, Cumberland Caverns is 44.4 kilometers long. So we'll put that's CC. Okay, that's 44.4 kilometers. This cave, so they're referring this cave to Cumberland Caverns, is 10.9 kilometers longer than Carlsbad Caverns. How long is Carlsbad Caverns? So we know that the 44.4 is 10.9 longer than Carlsbad. So what would we do to find Carlsbad? And you're right, we would subtract. I'm assuming you would say that. Because remember, Cumberland Caverns is longer. So we're going to subtract to find the Carlsbad. So we know that that's going to be 5, 3, and 3. And our label is going to be kilometers. Bocce. Bocce is a lawn bowling game that originated in Italy. The bocce court below has an area of 1,032 square feet. The width of the court is 12 feet. What is the length of the court? Well, it's a rectangle, so we know the formula for area rectangle is length times width. So we're just going to substitute like we did to that triangle up there. So I know my area is 1,032. Okay, I know that my width is W now. Or no, my width is, they're calling it 12. So I guess we'll call this length. So the length we don't know. The width is 12. So just like the earlier problems on solving equations, I have to get the L by itself. I'm multiplying by 12, so the opposite is dividing by 12. Those cancel. And I'm left with a simple division problem. 1032 divided by 12. 12 goes into 103, what, 8 times? That's 96. And 12 goes into 72 6 times evenly. So our length is 86, and we're talking feet. It's quite a long court. You throw the ball out there and you try to get it closest to a ball that you throw it originally. I'm not sure what that ball is called. You can knock balls away from other balls. It's kind of fun. Okay, speed skating. In the 2002 Winter Olympics, Catriona LeMay-Doan won the 500-meter race. Her winning time was 74.75 seconds. Find her average speed to the nearest tenth of a second. So this was speed skating. So she went 500 meters, and it took her 74.75 seconds. Now, we're going to make a rate out of this, because remember, speed is a rate. But we have to use her words. So, or the words in here. It says, find her average speed to the nearest tenth of a meter per second. So that tells us what way to write this. So our meters have to be on the top, and then our seconds have to be on the bottom. And then that shows us what we're going to do to find out how many meters per second. So this is a unit rate. So we're going to divide top by bottom. So 500 divided by 7475. So go ahead and do that. 500 divided by 74.75, and that gives me about 6.68. All right, so we're going to call it 6.9 because we're on to the 10th, and that's meters per second. So that's pretty good. Okay, you work at a grocery store part-time. You estimate that you spend 3/5 of your time stocking shelves. So that's most of your time. You work 20 hours each week. How many hours of work do you spend stocking shelves? We know of means times. So I'm taking 3/5 of my 20 hours to stock shelves. So we know that's actually going to be 3/5 times 20 hours. So we have just a simple multiplication problem. So instead of multiplying across, let's simplify first. 5 goes into 5 once. 5 goes in there 4 times. So I actually have 3 times 4 is 12. 1 times 1 is 1, so I don't need it. It's about 12 hours. And then check it, is 12 hours a little bit more than half of 20? And it is. Because remember, 3/5 is a little bit more than half of your time stocking shelves. Okay. Those are just two-step equations. I'll take some questions in class if you actually have some. Okay, let's go down to the bottom. All right, the output of a function is 5 more than 2 times the input. Okay, so we're talking about x and y are inputs and outputs. So it says that the output, which is our y, is 5 more than 2 times the input. So if we just start with x equals y, input equals output, we know that our output, our y, is 5 more than 2 times the input. Well, if we have to keep this equation equal, and this y is 5 more, then I know I'm going to have to actually subtract 5 from it. Okay, and I then know that this number here, y, is 5 more than 2 times the input. So if I take 2 times my input, which is x, and then I subtract 5 from my output, they're going to be equal. Now sometimes it's confusing because it says more than means plus, but you have to remember this is an equation, so one side has to equal the other. So if I actually add 5 here, that wouldn't make sense because we need to make them equal. If this side is 5 more, if this side is 5 more than this, to make them equal, I have to subtract 5 on that side. It's like saying, okay, you have $5 more than me. All right? If I want that to be equal, if I want us to have the same amount of money, you're going to have to actually take away 5 from your pile. And then they would be equal. So now we just substitute. I know the output is 17, so 2 times x equals 17 minus 5. So 2x equals 12. So x equals 6. Now, once I know that, we have some other problems that are exactly the same. So again, here's my x and my y. The output of a function is 10 more than 4 times the input. So output is y. So it's 10 more. So let's actually change this a little bit. Let's look at it this way and use the words. The output of a function. So we know output is y. We know is equal. 10 more means 10 plus 4 times the input. This is basically the same as this. If I were to have switched this around instead of y minus 5, if I were to add 5 to each side to get rid of it, I would have had this equation. 2x plus 5 equals y. It would have been the same thing. So now the output is negative 26 equals 10 plus 4x. And let's solve it. So I need to get rid of the number part first. So that's a negative 10. So that cancels. Negative 26 and negative 10 is negative 36 equals 4x. And then I divide each side by 4. They cancel. And x equals negative 9. Okay? And then the final one. So let's do that same thing. Okay, let's just take the words and change them into numbers and symbols. I have the output of a function, so that's y, is, which is equal, 14 less than 6 times the input. Now remember, this is one of those special ones. It's not 14 minus, it's minus 14. We learned that a couple weeks ago. And then we have 6 times our input. So we know that our output is 22. So I have 6x minus 14. Do our same chain switch. So opposite negative 14 is a positive 14 on both sides. They cancel, so I'm left with 36 equals 6x. And then you divide each side by 6. And x equals 6. All right, and then you can ask questions after this.